So in case anyone needs to watch this again, this is lesson 4.5. And we're just gonna go through these notes. The first part is some vocab. Everybody's with me, right? I'm not moving too fast. All right. First part is vocab, and these are triangles that you've probably dealt with before. So first it says we're dealing with isosceles and equilateral triangles. Do we know what isosceles means? I think back in like 5th, 6th, 7th, 8th grade.
Yes.
Max, tell me.
There's two sides that are the same, like congruent.
Two sides are congruent. Very good. And then how is that different than an equilateral triangle?
In an equilateral, all the sides are congruent.
Good. All 3 sides are congruent. Very good. Now, technically, an equilateral triangle is under the big umbrella of an isosceles triangle. So like what our textbook says is a triangle with at least 2 congruent sides is called an isosceles triangle. And an equilateral is just a specific type of isosceles. That's not that big of a deal for us. But in case we were to see that, it's saying equilaterals are a type of isosceles triangle. All right, now a couple vocab words on what's going on with this triangle. If we have an isosceles triangle with exactly 2 congruent sides, then the congruent sides are called its legs. And the third side that's not congruent is called the base. It makes sense if we look at that picture drawn. The base is that one on the bottom, and then the legs are the 2 sides that are standing up on top of it. So it's like legs on top of like a base, which I think makes a lot of sense when it's drawn this way. It's not always drawn this way, so we just have to make sure that we're looking where the sides are congruent to know those are called the legs, and then the other side is the base. The angles also have names. The angle that's formed by the 2 legs is called my vertex angle. And then the other 2 angles both have one of their sides is the base. And so the angles that have one side formed by the base are called base angles. Again, we're not that creative in math, very basic on what we already know. Okay, so those are some vocab things. Next, we're gonna do a couple theorems. Questions so far? All right, theorem-wise, the first ones are isosceles triangle theorem. So we don't have to remember that, we're just gonna remember what it says. It basically says if 2 sides are congruent, so if AC and CB are congruent, then their opposite angles are congruent. So angle A and angle B are congruent. Angle A, congruent, angle B. That's basically what it says over here. I just don't zoom out enough to look at the other side of the picture. Angle A is congruent to angle B. So if we want to say that in words, generally we'd say if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. Are congruent. All right, so if 2 sides are congruent, then their opposite angles are also congruent. We also can write it using our definition. We know a triangle is called isosceles if at least 2 of its sides are congruent. So if the 2 sides are congruent, we can just say if a triangle is isosceles, then, and again use our vocab, then our base angles are congruent. So this is a like theorem that we will have to write out. It's very similar to the ones where we said if lines are parallel, then corresponding angles are congruent, or if lines are parallel, then blah, blah, blah. It doesn't roll off the tongue as nicely, but these are the exact same ideas of my statements before, and we'll use them later so you'll know what it's like to use them. Okay, we also could be given angles first. So the converse, if you remember back in, what was that, chapter 2? I've said this a lot. It's not a threat, but you can't forget anything in geometry. So back in chapter 2, we did conditional statements and we did converses where they switch. So if I say this is the converse of the isosceles triangle theorem, it means that we're switching the hypotenuse and the conclusion. Instead of saying if 2 sides are congruent, then angles are congruent, we're going to switch it and say if my angles are congruent, then their opposite sides are congruent. Okay, so that's what this picture right here shows. If I knew that my angles were congruent, then I can say sides AC and sides BC are congruent. AC is congruent to BC. And again, that's written over there. The sides are congruent. Sorry, that's a funny side mark. whatever. In words, we'd write, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. And again, this is another theorem we're going to refer back to in a few minutes. All right, any question on the vocab or the theorems that we've just talked about so far this note sheet? All right, now we're going to do a problem that's going to use the idea of these theorems and of these vocab words. So the first one says, is AB congruent to CB? Explain. All right, there's a lot going on there, so I'm going to redraw this picture and bring it over here. It's close enough. All right, I know I've got A, B, C. It says, is AB congruent to CB? If I redraw this picture, I also need to remember that those angles are marked congruent. And then I've got this side marked congruent, but that's not on my AB. It just goes to AD, and I didn't include D here, so I don't need to mark that. Are my sides AB and BC congruent?
Yeah, because you'd use the converse, because if the angles are congruent, then the sides opposite are also congruent.
Good job, Ava. So we know that the angles were congruent. That was given to us. And so that means that the sides opposite it are also congruent. So I can say yes. I'm going to say yes, AB is congruent to CB. And I love that Ava used the theorem because that's what we're going to use. We're going to say if, and I'm going to just change the wording a little bit. I'm going to say if triangle has two congruent angles or two angles congruent, then opposite sides congruent. That's about as simplified way as I can say it. So if triangle has two congruent angles, then opposite sides are congruent. Very good, Ava. Any questions on that one so far? Okay, the next one says, is angle A congruent to angle DEA? So let's go in here. I'm looking at angle A, and I'm looking at angle DEA, which is right here. Somebody I maybe haven't talked to yet. Are those angles congruent?
Yeah, they are.
Yes.
Yeah, Silas, why are they?
Yes. Because you can tell that, I mean, since it's an equilateral triangle, you're going to assume that those, or you can basically just hypothesize that those angles are going to be congruent.
What kind of triangle is this again?
Isn't it a, oh, sorry, it's an isosceles.
An isosceles triangle, very good. And you were just talking off of your head, but you also almost said a theorem that we just learned. The triangle is isosceles, so then we get to know that the base angles are congruent. You also could say if two sides of a triangle are congruent, then the angles opposite are congruent, and I'm going to write both. But yes, very good, Silas, they are congruent. So I'm going to go down here and write that. Yes, angle A is congruent to angle DEA. And then going to use one of the theorems from the isosceles triangle theorem. So you can write one of two things. The first one I like to write the best. This is the one I usually write. If triangle is, sorry, let me write a little bit neater, try a little harder. If triangle is isosceles, then base angles congruent. You also could write the other statement that's if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And I would abbreviate it like this. If triangle has two congruent sides, then opposite angles congruent. These mean the same thing, kind of like yesterday where I taught you definition of congruent triangles and what was the other one? Corresponding parts of congruent triangles are congruent. Those I said were interchangeable, so are these. I personally think about isosceles first, but they mean the same thing, so go for it. All right, any questions on where we're at? Give me a thumbs up if you're with me. Either in person or your little emoji. I see 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11. Awesome. Good job, guys. Good job. Okay. Let's go and do these couple examples with me. Thank you for jumping in, making sure I'm with you. I don't get to see your beautiful faces in person, so I got to check in another way. Okay, we have to solve for these variables and we have to write our statements. So you're going to have like a column of statements and then math worked out off to the side. I'm going to help us guide through these, but we're all using the idea of isosceles triangles right now. So I've got these two triangles kind of right on top of each other. I have 70 degrees and then I have y. I think we can easily find this angle next to 70 and that will bring an angle measure into my triangle on the right. Does anyone know how I would find that highlighted angle?
Subtract 180 or 70 from 180.
Why?
Because the triangles are, it would add up to be 180.
Yes, but tell me more. 70 and that angle are not in a triangle. What is their relationship actually?
They're a linear pair.
That's it. That's what I was looking for, Ava. Good job. They're a linear pair. So I have these two angles right here, and we have a linear pair, and we know linear pairs are what?
Supplementary.
Supplementary.
Awesome. Good. I love that people are chiming in on that because that's something we all should know, right? Linear pairs are sup. And as Ava said, we can find this by minusing it from 180. I am going to set up an equation because I'm a math teacher and I like equations, nice and neat and orderly. I'm just going to call that variable x because I don't have x in my picture and I don't know what it is. We can't always do that, but we can in this case. So I'm going to minus 70 from both sides. Am I writing? Maybe I'm not. Okay, there we go. Minus 70 from both sides, and I get x equals 110. All right, so I'm going to go erase this and put 110 in here because there's technically no x, so we'll get rid of that. All right, now I'm focused in on just that triangle to the left, or to the right, sorry. Left and rights are hard today. I'm looking at just this triangle. I can know what this angle is up here. Does anyone know what that angle is at the top based on just the yellow triangle? Anybody?
Is it 35?
We don't know it's that yet. Why do you think it's that?
Oh, I just thought there was two more angles, and then I just divided the degrees we had left in half.
Okay, awesome. You did exactly what I want, but you did it too quickly. This angle is the same as which other angle that's already written on my paper?
It's
70.
the
70.
7.
Not 70. Awesome, you know that my sides were congruent, so we can use another y to represent that.
Oh, yeah.
Is that what you were thinking? So Austin literally
Yeah, kind of.
solved a whole equation for me, but all I was looking for was this angle is just y. So this is y, and now I'm going to set up my equation. Before I do that, though, I do want to write why this is y. Does anyone know why we know that that angle right there is called y? What's my reason?
Because those sides.
Isn't it because
Congruent marks.
Yeah, I heard a bunch of people help me out. I've got congruent marks. The sides are congruent. What we're going to say officially is because the two sides are congruent, then the base angles are congruent. Or my favorite, if a triangle is isosceles, then base angles congruent. Very good. So that's why that's y. And then Austin said something about 180. Why do I get to add all of these up to 180? Oh, not 70. Can anybody tell me why?
All three angles.
Sorry, say again?
All three angles of a triangle adds up to equal 180.
Very good, Silas. Do you remember what that theorem is called?
The third angle theorem.
Not the third angle theorem.
All right.
Triangle angle theorem.
Right guess. But Ava, I think you got it. Say it again.
Triangle angle sum.
Good, triangle angle sum theorem. That one is like such kind of like a a mess in my mouth and my brain that I don't always remember it either, but it's something we all know. We know all the angles in a triangle add up to 180, and so that's the official name of it. All right, now that we've said all of our official words about how we can set up this equation, let's solve this. And I believe it's what Austin told me like 20 minutes ago at this rate. Combine my two y's. I'm going to minus my 110 from both sides. Sorry, I'm outside the box. I'm going to divide by 2, and I get y equals 35. So we do need to make sure we show all of this work on how we got there so that I know what you're doing. All right, any questions so far? All right, let's go to the next one. What do we got going on this triangle? What do we see?
It's isosceles, so the two, so 75 would be equal to 5x, so those would be congruent.
I'm gonna pause right now, Ava. Good job. You said everything right. Let's write our statement out. You said it's an isosceles triangle, so 75 and 5x are congruent. So we're gonna write it officially as if a triangle is isosceles, then base angles are congruent. And if we know they're the same, we're just gonna set them equal. So 5x equals 75. Everyone good so far? Any questions? Okay, divide by 5. X equals not 12, 15, I believe.
13. Oh wait, no, 15.
Am I right with 15?
Yeah.
Okay. Okay, good. 15. Okay, that gives me X though. Can somebody new tell me how to find Y?
You add, well, first you have to plug in the X again, and you add it to the 75, and then plug it into a subtraction from 180.
Good, let's write a whole equation. We're gonna add what things up to equal 180?
So it'll be 5 times 15
Yep.
plus 75 plus 3y equal 180.
Very good, Gwenna. And does anyone remember what tells me I'm allowed to add all my angles up to be 180? We just did this one.
Triangle, angle, sum theorem.
Awesome, good job, Gwenna. Triangle, angle, sum theorem. So 5 times 15 is 75. 75 plus 75 plus 3y equals 180. My 75s become 150. Minus my 150 from both sides. So 3y equals 30. And then my last step is to divide by 3. So y is equal to 10. Awesome. Great teamwork on that problem, guys. Any other questions so far? All right, so we just did 2 examples where I told you sides were congruent, so then we could assume what angles were congruent. Now I'm going to give you sides. Is there any way that I can add all these sides up to equal something? Is there like a theorem that says I can add all the sides of a triangle to equal something?
Can't you add them up to 90?
If they were angles that had another 90 degree, we would, but there's nothing that tells me what sides should equal. They could equal like 2, or they could equal like 50,000, 100 million, kajillion. We don't know what they're going to equal.
Couldn't we just solve for x?
Yeah, how do you want to solve for x, Van?
Just like put x plus 10 plus 2x plus 6 plus 3x minus 6 equals 180.
So that would be awesome, Van, if I was having angles. But these are all sides.
Oh.
Yeah.
Can we set them equal to each other?
Gwenna, what do you want to set equal to each other?
The sides. 2x plus 6 and 3x minus 6, because they're congruent.
Good. Why are they congruent?
Because it's an isosceles, or no, it's an isosceles, right?
What do we know?
That there's 2 angles that are congruent, which means 2 sides are congruent.
There we go, Gwenna. We know if the 2 sides are, or the 2 angles are congruent, then the 2 sides get to be congruent. Awesome. So I'm going to say if And I usually say if a triangle has two congruent sides, because if we just, or sorry, angles, if I just say two congruent angles, we'd be like, where are they? So we have to say if a triangle has two congruent angles, then opposite sides are congruent. And we know that SV is congruent to TV, which is why Gwenna wanted to set 2x plus 6 equal to 3x minus 6. So basically this x plus 10 was kind of a distractor. He doesn't do anything. Kind of confused us. Any questions so far? All right, let me finish solving this. Minus my 2x.
It's 12.
It's 12. Thank you, Ava. Sometimes when we get -6 and +6, you're like, oh, it's going to be 0. Well, hold tight and make sure that you do your inverse operations to get it to be 12. Whew, okay, we did the first side. Any questions? Comments? Concerns? Thoughts? Feedback? Okay, now I'm just being silly. Okay, flip your paper over, scroll down, whatever you need to do. We've got a couple more problems on the next page. And before we do those problems, I'm going to talk about these two corollaries. Corollary is like a mini theorem. It's a theorem that follows from another theorem. They're kind of like those oh duh things. It's like not enough new information to make its own theorem, but it's a little bit different than the theorem that was told to us.
Haven't we gone over these before?
We might have gone over the word corollary before.
I think we have.
Okay. I can't always remember, and so sometimes it's like units between them, so I can't remember, so I just throw it on there as a definition in case we forgot. This corollary today that we're talking about goes from the isosceles triangle theorem, and so the first one says, if a triangle is equilateral, then the triangle is equiangular. Okay, stop. What does equilateral mean?
All three sides are equal.
Good. I'm just going to say generally all sides congruent. That being said, what is equiangular?
All angles congruent.
All angles. Thanks, Ava, for that. All angles are congruent. I don't know if you guys have heard the word equiangular before, but just off of like context clues, if we know equilateral means equal sides, then equiangular means equal angles. It's just a little bit of, I don't know, logic, reasoning that we use. So even if you've never heard it before, it's all my angles are equal. You might have been like, well, dumbass, why we knew that. But sometimes we know things that still had to be taught to us that still have to be proven. So all I'm saying is that if I told you all of my sides were congruent, x, y, y, z, and x, z, then I know all of my angles are congruent. X, y, and z are all congruent. That was my normal isosceles triangle. Now I have to do the converse. So if I just said, if it's equilateral, then it's equiangular. Now I switch and say, if it's equiangular, then it's equilateral. So if I give you all of the angles are congruent, then I get to know all my sides are congruent. So it just kind of goes both ways. That being said, we just talked about equiangular a couple times. What is that measure of all the angles in an equilateral triangle if they're all the same? What's their degree?
For each separate one, or just all of them added up together?
Each separate one.
They would all be 60.
Why do you know that, Ava?
Because the triangle angle sum theorem and equilateral triangles, all the angles are equal, so they'd all be 60.
So if I know that they're all the same and I know that they add up to 180, if I didn't know, I could just set 3x or x plus x plus x equal to 180, and then I'd get x equals 60. So 60 is the only thing added together 3 times that equals 180. Awesome. That's maybe not something I'm going to test you on, but like I'm going to test you about equilateral triangles, so it's probably really helpful to know that it's 60. All right, the next one says, what are the angle measures of an isosceles triangle? I think I wanted it to be an isosceles right triangle, because that's way more interesting than just an isosceles triangle. Let me make it a little bit more to scale. Okay, so an isosceles right triangle has a right angle, and then these two are my legs that are congruent. And so I want to know what these angle measures are. Someone I haven't heard from.
45.
Why is it 45, Van?
Because I know 90 and 90 is 180, and then half of 90 is 45. So
Good. So Van was like, okay, this one's already 90, so the other two angles must add up to be 90, but I have to divide it evenly between the two angles. So you can think of it as 90 divided by 2, which is 45. Awesome job, Van. So the angle measures are 45, 45, 90. Ooh, I don't know, the little preview for the rest of your life. We're going to be talking about 45, 45, 90-degree triangles in geometry and in pre-cal in 2 years. So it's a fun little first step into our journey of triangles. Okay, any questions so far on what we've done? I've got 2 more problems and a little proof. The proof is only 4 steps. It'll go pretty quick. And these next 2 problems are like what we just did on the first page, but have a lot to do with what we've just done in here. Any questions before I start solving them? They just say solve for the variable, so I don't have to write any statements down. I can just solve. And let's start by solving to find x. I want to find x first. In order to find x, I need to know this angle over here. Does anyone know what that pink angle is?
70.
Why?
Because the 2 sides are congruent, and which would make the 2 angles congruent, which would be the converse of the isosceles triangle theorem.
I think it's just the normal isosceles triangle theorem. Just,
Yeah, it's the normal one. My bad.
okay. If it's an isosceles triangle, then the base angles are congruent. So then this is also 70. Awesome. Good job, Ava. Somebody else tell me now, how am I going to find x? How do I find x now?
You add 70 plus 70 plus x equals 180.
Awesome, Silas. 70 plus 70 plus x equals 180. All my angles in a triangle add up to that. 70 plus 70 is 140 plus x equals 180 minus 140. X equals 40. Okay, we didn't even need that in order to find y. That being said, let's focus in on this triangle right here in yellow. Somebody I also haven't talked to for a minute. What kind of triangle is that?
Equilateral.
Very good, Isaac, equilateral. And then I need to know what my angle measurements are. Who knows what my angle measurements are?
Those are 60.
60. Very good. All right, I believe now I have enough information to find that yellow angle. Who have I not talked to who can help me with that? How do you think we can find that yellow angle?
Is it a linear pair with 70 and 60 because it makes a straight line?
Very good, Bethy. This time we don't call it a linear pair because like you said, it's with 70 and with 60 and this other angle. So 3 isn't a pair, but we'll just call them supplementary. So they are supplementary, which means that 3 of those angles add up to what?
180.
Very good. So I'm going to say 70 plus 60 plus, and I'm just going to use a little question mark. I know that's maybe not best practice, but I think it's kind of fun. This little new angle we don't know. Add those 2 up, minus from 180 to find my missing angle. 70 plus 60 is 130 plus question mark equals 180 minus 130. My question mark equals 50. Nice. So that new angle right here is 50. Perfect. Now that I've got an angle on this side, I've got to figure out what y is. So someone else I haven't talked to for a while. I want to find y, but let's first find this angle. What's this angle called?
Is that a base?
It
Base
is
angle?
a base angle. And what, do I use a number or a variable to represent what it is?
I don't know.
Okay.
Use a variable.
What is it?
Would you label it y?
We would label it y. Do you know why?
Because those 2 sides are congruent.
Because
The y's.
awesome. I can't find who's talking to me.
Amanda.
There you are. Sometimes it pops up and sometimes I have to go searching for you, so I didn't see you. Yes, Amanda, it is y because I have my sides right here, and then y and y are both my base angles. So Austin, you were right, they were base angles, but I wanted to know specifically what it was. Now that I call that y, how do I find y?
You'd set
You
up
would just
Go ahead, Amanda.
you would do y plus y plus 50 equals 180.
Perfect. Y plus 50 equals 180. Angle, triangle, angle, sum theorem again. So I've got 2y plus 50 equals 180. Minus 50, I get 2y equals 130. Divide by 2 and I get 65. Awesome. All right, I'm going to leave that up, but I'm going to keep chugging so we can get all of this done in the next 5 minutes of class. Next problem, I've got a right isosceles triangle. I want to write 3x plus y plus 7 plus 90 equals 180. But why is that wrong? Why can I not do that?
Because not all of the angles are congruent, I think. Wait, no, never mind.
Okay.
Yeah. No.
Okay, not what Silas said. Somebody else. Why can I not write what I wrote?
You have too many variables.
Too many variables. I can't solve with an x and a y, right, Megan?
Yeah.
Instead, I got to do something with those individually. Does anyone know what I do with those? Anyone know what they're equal to?
Aren't they equal to each other?
They are
90.
equal to each other. And they together equal 90. But both of you said good things, but I can't set them equal to each other because I can't solve.
I know what you do.
Okay, Silas is coming in hot. Give me 1 more second to prove it, Silas. You also can't
So
add stuff equal to 90. So what do you want to do, Silas?
You can make either x or y 0, right? Can you? Can you?
I don't think so. I love
Are they both?
Sydney, go ahead.
Are they both equal to 45?
They are. Do you remember why?
Because so one angle is 90, and since the two are congruent, they'll both add up to 90.
So together they add up to 90 and they're the same. So the only way to do that is 45, 45, 90. Very good, Sid. I have to add them up, set them equal to 45 individually. Oop, not 48. And I get x equals 15 and y equals 38. Awesome. I made us problem solve through this because it is as simple as just setting it equal to 45. But sometimes if I just tell you that, we forget. And so we were like, okay, well, we want to do this, we can't. We want to do this, we can't. We want to do this, we can't. Finally, we found that they both equal 45. Great teamwork on that, guys. Good job. All right, while you're copying that down, I'm going to tell you what the proof looks like. It goes statements and reasons, and there's just 4 parts. I say angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. Angle 1 is congruent to angle 3. And then last, I'm ready to prove AB is congruent to CB. We're kind of going to do a speed proof. Is everyone ready? All right. First one, why do I know 1 and 2 are congruent? Anybody?
It's a given.
Given, very good. How do I now know that 2 and 3 are congruent?
Vertical angles are congruent.
Awesome, vertical angles are congruent. Okay, so now I said 1 and 2, 2 and 3. Why do I get to say 1 and 3 are congruent?
Transitive property.
Awesome, very good. That's one that we often forget. I love that you guys didn't forget it, transitive property. And then last, why am I now allowed to say AB and BC are congruent?
Definition of congruent.
Because
So we don't have congruent triangles yet.
it's because if 1 and 3 are congruent, then the 2 sides are congruent, like the thing we just learned.
So what we just learned about is if the 2 angles are congruent, then the 2 sides opposite them are congruent. So we're going to write this. We're going to say If triangle has two congruent angles, then opposite sides congruent. So that is the new thing we learned today, is if I've got sides congruent, I've got angles congruent. If I've got angles congruent, I have the sides congruent. Whew, all right, we did it. I'm gonna go post your homework right now during this passing period. I'm gonna stop recording. If you need me